Hello students, we are in fourth assignment today. In this video we will address first question of fourth assignment. The question is, write expression for intensity of resultant wave due to interference of two coherent waves. Using it, obtain expression of intensity in terms of distance x from the central point on the screen and distance capital D from source. So let us start with the expression which we saw previously, and then first we'll understand the situation and then we'll try to derive expression. What we are talking about is, sorry, a situation in which we have two sources of light coherent luckily, and this is the perpendicular bisector for the line of two sources S1 and S2. Let them be. We consider the gap to be small d and this distance to be capital D. So this point becomes center, let it be O. Now we know that when you consider waves coming from S1 falling on O, waves coming from S2 falling on O, their paths are equal. So if this is R1 and if this is R2, what will happen at point O? Whichever number of waves you have accommodated on this path R1, you will have same number of waves on this path R2. And then if you are asked what is the path difference, so at point O, path difference, that is R2 minus R1 is 0. And what if the path difference is 0? The equation says that intensity is 4I0 cos square K R2 minus R1 by 2. R2 minus R1 is 0, so this whole term it is cos 0, and then intensity is 4 times I0. It means that at point O you will have constructive interference taking place. Fine. What if we go further? Slightly up if we go, suppose at this point if we go, what you are doing with R1, it will be reduced, R2 will be slightly more. So from R2 minus R1 is equal to 0 lambda condition, we are going to R2 minus R1 to half lambda condition. Along this line, there will be some point where difference of R2 and R1, you are increasing R2. As you go up, you are increasing R2 and you are decreasing R1. So obviously the path difference will not be 0 lambda anymore. So at some point the difference has to be half lambda. So what will happen at that point? Intensity will be 0. Further if you go, maybe somewhere here, the difference of R2 and R1 will be 1 lambda. So intensity will be again 4 times I0. Again further if you go say at this point, you may find that the R2 minus R1 is 1 and half lambda, 3 by 2 lambda. Intensity will again be 0, and that continues. It means that on the screen, in some part the intensity will be maximum, in some part intensity will be 0. So overall, let me draw the diagram again. If this is S1, S2, and if this is our screen, then on screen we will see that intensity is maximum here, it reduces to 0, that is true on other side also, it will again be maximum, again it will be 0, again it will be maximum, and so on. So what is happening? This is the point where intensity is maximum because the path difference R2 minus R1 is 0 lambda. This is the point where intensity has fallen down to 0 because path difference R2 minus R1 must be half lambda there. What must be the case here? where intensity is maximum. So you should understand that as it is first maximum after 0, path difference has to be 1 lambda, path difference has to be 1.5 lambda, and so on. And this is applicable even on this side also. Okay, path difference has to be half lambda, path difference has to be 1 lambda, 1.5 lambda, 2 lambda. So this pattern which we get on screen is called interference fringes. Interference fringes. Now the question is, can I predict exactly at what distance, at what value of x is distance from center, at what value of x I'll have first bright, or at what value of x I'll get second dark. So can I have some equation by which I can predict, I can find out that at this distance I'll have fifth dark occurring or second bright occurring. So can we have that type of equation? Surely we can have. For that, I'll need to draw the diagram once again. Let me draw the diagram once again. So again, two sources, again screen, again perpendicular line, and point O, S1, S2, difference is small d, and this gap is capital D. And now I will not consider point O. Instead, I will consider some point P. And we know that if we draw foot of perpendicular from R1, let this be R1, let this be R2, and you can always have one central line for reference. So now, if you draw foot of perpendicular, say here, now say this part, uh, I'm drawing separately, R1, R2. Once you draw foot of perpendicular, these paths will be identical, and hence whatever is the path difference going to occur, it is because of this part. Let me call it M. So S2M is the part which is creating path difference, and S2M will decide what will happen at point P. Okay, so I may refer it as R2 minus R1. And you can prove from geometry of figure that if this is theta, this angle has to be theta. So intensity equation is I is equal to 4 times I0 cos square K R2 minus R1 by 2. Let it be equation 1 for now. And now in triangle S1 S2M, if you see, this triangle I am talking about, S1, S2, and this angle is theta, and this is D. So if I apply sine theta formula, can I say sine theta here is opposite, that is S2M upon hypotenuse, that is S1, S2. So for small angle sine theta can be written as theta, S2M is R2 minus R1, S1M is D. Let it be second equation. Similarly, if you consider another triangle, so let me call it S, SOP. See, SOP looks like this. SOP. Let me label this distance as X. So this is X, this is D, and this is theta. So in case of SOP, if you take tan theta, what is tan theta? Opposite OP by adjacent SO, and then for small angle tan theta is theta, OP is X, SO is D. So from second and third, can I say R2 minus R1 by D is X by D, and then what is R2 minus R1? It is X D by D. Substitute 4 in 1. This is 1, this is 4. and then I is 4I0 cos square k x d by 2d. So this is our equation of intensity once again, but now this is in terms of x and capital D. What is x? What is capital D? Distance of the given point from center on the screen, and capital D is distance of screen. So this is new equation which will help us finding out exactly where on the screen constructive interference will take place, and at which point destructive interference will take place, which we'll see in next video. Thank you.